Hi grade 12s, this is my favorite part of calculus in a section called optimization. And the reason why it's my favorite part of calculus is this is the whole reason we do calculus in grade 12. To get to this idea about optimizing a situation. Now, what does optimizing mean? Optimizing means finding the best solution. So this is where we actually use calculus in real life. There's loads of situations and jobs that require people to find the best solution. Maybe people are trying to maximize profit, or maybe they're trying to minimize cost, or minimize the surface area for the box that they're making for the cereal, so they have to pay for less cardboard. All those types of things. Minimize the heat lost in pipes within a house in order to make it more green. There's loads of situations where you try and find the best solution. So this is really important, and every single exam will have an optimization question. So what we're going to do is do a couple of examples and then fill in notes as we go along. So this first question says, consider the box. Now what actually happened here is you had a piece of paper which had a breadth of 50 centimeters and then a length of 80 centimeters. And in order to make it into a box, imagine this was a cereal box or something. In order to make the cereal box, what they've done is they've cut out little squares, x by x centimeters, in each corner. So by doing that, they've created a fold line in each of my dotted lines, and they can fold along my dotted lines, and they can make a three-dimensional box. So here's my three-dimensional box. This three-dimensional box will have a length and a breadth, and the question is, what is the length and the breadth equal to? Well, let's first look at the length, because you'll notice the first question says write down the length, breadth and height in terms of x. So first of all, the length, well, the full length of the box was 80 centimeters, but then I removed x, or I removed that x, so I moved x over there and I removed x over there, and so this becomes 80 minus x minus x. So immediately I know that my length, if I rewrite that in a more simplified fashion, is 80 minus 2x. Now if I go to my breadth, it's the same concept. My full breadth was 50 centimeters, but I've removed x there and x there. So my breadth is actually this length there, which is 50 minus x minus x. So my breadth is 50 minus 2x when simplified. Now my height of my box is just my x, which they have actually labeled in the picture. So my height is x centimeters. And there we go, I have a box. Notice that we always use one variable in these questions. We can't have two different variables. So everything will always be in terms of x, or in terms of y, or in terms of a. Only one variable though. Right, let's look at the next question. Write down a volume expression for the volume of the box. Now, first of all, let's just quickly recap volume, because this is where measurement from grade 8 and 9 comes in, and we're probably a bit rusty. A box is a type of prism. Now, what a prism is a three-dimensional shape where you take a base shape and you basically just stack a whole bunch of that shape on top of itself to form 3 dimensions. So a rectangular box is a prism because you basically take a rectangle and stack a whole bunch of rectangles on top of each other. What else is a prism? Well, you get a triangular prism, which is like a Toblerone box, which has a triangular base. That would be called the base of your prism, because basically you've stacked a whole bunch of triangles on top of each other. And then we have a cylinder, which is basically when you take a circle and you stack a whole bunch of them on top of each other. So those are probably your 3 most common prisms which they like to bring up. And we need to remember what volume of any prism is. Volume of any prism is area of the base of the prism times the height of the prism. Now don't forget, what's the base? The base is the shape that got stacked on top of itself. So either the rectangle or the triangle or the circle, that's the base. The height is how high you stacked these shapes on top of themselves. So that would actually be the height of your triangular prism, which often confuses people. Right, well, this one's easy because my area of my base is just length times breadth times height to complete my formula. So my length is 80 subtract 2x, my breadth is 50 subtract 2x, and my height is x. Now notice they didn't say in simplified form, they just said write down an expression. There is my expression for my volume. Now if you look at the next question, this is what optimization is. This question says, can you find me where the volume will be a maximum? Now how would you possibly find a maximum? Well, the first question I'd ask myself is, what does this volume expression actually look like? I haven't multiplied it out, and so I don't actually know what type of graph this is, because I could graph this expression for volume. So if I multiplied it out, let me put my x in the front, I would multiply my two brackets first, so that would be 4,000 minus 160x minus 100x plus 4x squared. Let me just move that bracket, 4x squared. Then if I multiplied by x, I got 4,000x minus 160x squared minus 100x squared plus 4x cubed. And preferably, I'm going to write that in descending powers of x, as in your highest exponent first, then your next exponent, and then finally just your x's. So let's look at this. Sometimes these models, is what we call them, we've made an expression. This model is sometimes a graph that you actually could graph, and sometimes it's a graph that I have absolutely no idea what it looks like. Ultimately, it doesn't actually matter, because it all comes down to the fact that how do you find the best solution? Well, let's think about it. This is a cubic. It has a positive coefficient of x cubed, which means this graph either goes up, turns, goes down, and goes up again, or it goes up, it's stationary, and it goes up again. Those are the two possibilities for this graph. Now again, you don't always know the picture of the graph, but it's the same concept every time. Now, it's a little bit of a hint here, but you only ever get questions where they ask you this one. Because if they ask you this second option here, to be honest, there is no maximum, because there's no local maximum. So what the graph does is it goes stationary and then it goes off to infinity. So there isn't a local maximum that occurs. And so these models always, if they land up in cubic, they always land up with a graph that turns twice. So the question is, if it is the first graph, how do we find where the volume is a maximum? Well, there's the maximum. This would be the minimum, but there's the maximum. And ultimately, even if you don't know what the graph looks like, the maximum or the minimum solution always happens at a stationary point. And so if I go back to write a note on this, if I go back here, no, gone too far. If I go back here to write a note on this, optimization is always about finding a stationary point, because that is where the graph maximizes momentarily. And how do we find a stationary point? We take the derivative and we set it equal to 0. So ultimately, every single one of these questions comes down to making an expression to model the situation, differentiating and setting equal to 0. Every single one of them. So if I have a look at this now, I have found an expression. I now need to find the derivative of volume with respect to x. You could have called it v dashed if you were being lazy. So if I bring down my 3, I get 12x squared minus 520x plus 4,000. And then you must explicitly state that you're looking for where this derivative is 0. Now, these numbers look big, and they often are strange numbers, and they're quite big. So if you want to go straight to using the formula, definitely a good idea. Personally, I'm going to divide by 3. So I'm not by 3, by 4. Oh, no, I've written the wrong thing. Divide by 4, so this is 3x squared minus 130x plus divide by 4 is 1,000. Now, those are quite big values, but I know that 3 has to be 3 and 1. So maybe this will be easy to do without the formula. If you struggle for longer than a minute, just use the formula. So I think I'm going to do this, because 100 times 10 is 1,000, and I could do 3 times 10, so 3 times 10, and 100 times 1, and that would make 30 and 100, which would give me 130. Now you want it to be negative 120, so I think it's a minus and a minus, which lands me up with the fact that 3x minus 100 could be 0, which means 3x could be equal to 100. So x could be equal to 100 over 3. You can leave it as a fraction, there's nothing wrong with that. Or x could be 10. Now we just have to ask ourselves which one of these solutions is right. Because if I look at my graph, I know that there is a local maximum and a local minimum. So now my question is which one? Well, if I just look at my question, I knew that this was a positive coefficient, so I know that it's going to maximize first and then minimize. Now, which one of these numbers comes first? 100 divided by 3 is 33,33, which means I think that 10 will be the first stationary point, and 33,33 will be my second, which means this is not the solution I'm looking for, and my solution is x is equal to 10. Now, let's just go check. Did they want the volume? No, they said for what values of x will the volume be a maximum? And so as long as I've crossed out the answer that isn't applicable, I've said the answer is 10. Now, why doesn't 100 over 3 work? Well, if x was 33.33, could it be? Well, let's just look at this. If this was 33,33 and this was 33,33, what would the breadth be? Well, it would be 50 minus 33,33 minus 33,33. Now, that's like negative 16,66 or something. That's not at all possible. So there's always a solution that doesn't actually work in this situation. And the important thing to realize is, yes, this is an expression for the volume of the box. But models only ever work in certain domains. In fact, there's a maximum value that x can be. Would you agree that there's no ways that x can be bigger than 25? Because if I took away 25 there and took away 25 there, I'd basically be folding my paper in half. So actually, if I look at this graph only actually applies to this situation in a narrow range for x, which is why this 33.33 isn't actually ever going to work. X also has to be bigger than 0 because you can't cut out a negative distance. And so this is a model, but the equation only works for a certain domain of x. Cool, so hopefully from this exercise we've learned that these questions are about modeling the situation using an equation and then finding the stationary points and then choosing which stationary point is the applicable answer. Right, let's look at another one. This question says a rectangular window is divided into one part that is square. The total length of the wood available for all the framework is 12 meters. Let the length of one side of the square be x. So basically that means this is x, this is x, this is x, this is x, and this is x. Now it says show that the area of the glass will be, and there it is. Okay, so what they're doing is they're asking me what is the area of this entire thing. Well, that's a rectangle. And the area of a rectangle is length times breadth. Now, there's actually two ways to do this. And probably the first way we would do would not be the easiest way. So, let's do the difficult way first, because it's probably what our brains would most logically do. Personally, I would go make this y and this y. I need to know that distance there in order to be able to answer this question, because that means that I could do the length would be x plus y and my breadth would be x, which actually means my length would be x plus y and my breadth would be x. Now you'll notice there's no y's in the formula, and that's because every question can only be modeled using one variable, which means I need to first find out the value of y in terms of x. So they needed to give me some information that connected x and y. And what information was that? The total length of the frame is 12 meters. So if I have a look at this, that means that x plus x plus x plus x plus x plus y has to equal 12 meters. 1, 2, 3, 4, 5 x's, and 2 y's will have to equal 12. Now, these questions are often like this. They'll give you a bit of information so you can find a missing variable in terms of the x, just so that you can create an equation but just with one of the variables. So now we need to solve for y. So this is 12 minus 5x would be equal to 2y. So 12 minus 5x over 2 would equal y. Now, I wouldn't be surprised if you started thinking we'd done something wrong, because if you look at the formula, this is 12 minus 3x. Where does that come from? Well, don't sell yourself short just yet. So basically what this means is x plus y, which is actually 12 minus 5x over 2 times x. Now notice my x is good. That makes sense. This needs to simplify, and hopefully it simplifies to 12 minus 3x over 2. Well, let's check. How do I add fractions? I need the same denominator. So this would be multiply the top by 2, multiply the bottom by 2, plus 12 minus 5x over 2. And what do you know? This is actually going to work out, because 2x minus 5x is minus 3x. This is 12 minus 3x all over 2 times x. So those two combined. So actually I got the right answer. Now, they often like to give you these answers simply because if you can't do it, then you can't do the rest of the question. So they like to say, show that the area is, and then give you it, because otherwise you can't possibly do B, and that's where all the marks are. So they will often give you the formula. Okay, so what was the easier way to do it? The easier way to do it would be as follows. What some people would look at is not putting those as x. Let me erase this. And rather thinking as the entire length as y. So then those people would now say area is length times breadth, and my length is actually y, the whole thing, and my breadth is x. And now I need to find y in terms of x, except what your equation now is that 1x, 2x, 3x plus 2y's is 12. So 2y is 12 minus 3x, and y is equal to 12 minus 3x over 2. Which means you directly get that, oh, that looks terrible. You directly get that 12 minus 3x, and then I can go pop it back in there. So that's the easier way to do it, but I probably wouldn't have seen that the first time I'd done it. Now, just the most important thing about a question like this, if they say show that the area of the glass is, make sure that you show every single step. Because they've given you the answers, they're not very generous with marking. They have to see that you knew what you were doing, as opposed to you just guessed because you could see the answer. Okay, so now the question says, what dimensions of the window will allow for the maximum area of the glass? Well, I don't really care what this graph looks like. I'm not even going to think about it, because I know that maximums or minimums, I should say maxima or minima, occur at a stationary point. So basically I just need to probably multiply this out. So this is actually 12 divided by 2 is 6 minus 3x over 2. So if I just divide each term by 2 separately and then multiply out, I get 6x minus 3x squared over 2, and that's a formula for my area. So now this is where if I'm trying to maximize or minimize, I need to take my derivative and set it equal to 0, because every single one of these questions are about finding stationary points. So if I go find the derivative of the area with respect to x, or a dashed, bring down the 1 and the x disappears, minus, bring down the 2 and the 2's will actually cancel, and so minus 3x. So I'm going to make my derivative equal to 0, 6 minus 3x, so 3x equals 6, and x is equal to 2. So when x is 2 meters, this will maximize the area. Now, I could have done this a different way, because once I'd multiplied it out, I realized that, oh, that's just a parabola. And there's multiple ways for finding the turning point of a parabola. But to be honest, I find this way the easiest. And often the models we actually make are not functions that we can draw, because we don't know what they look like. So it says, what dimensions of the window? Well, there we go. Dimensions. Did we answer the question? Dimension means what must the specs be for the window? What's the length and what's the breadth? So clearly, my breadth here is 2 meters. But if that's 2, and that's 2, that would be 2, 4, 6 meters gone, which means I'd have 6 meters left, so that would be 3 meters and 3 meters. So basically, my dimensions, it would have to be a 2 meter window by a 3 meter window. And now I've answered my question. Right, let's move on to example number 3. Example number 3 says yogurt is sold in a rectangular cardboard container as in the diagram. The volume is 1 liter. So there's the bit of information that they're giving me. So the chances are is that I'm going to need that information to connect variables. This fits into the rectangular part of the container, as in not in the top. So the top, which is folded, requires 3 times the area of the cardboard that is required for this rectangular base. The base of the carton is a square with dimensions x for each side. So actually this is a square base and its area is x squared, which would mean this funny triangular top would be 3x squared in terms of area. And then it says 1 centimeters cubed is 1 milliliter. And what is 1 liter? 1 liter is 1,000 milliliters, which is therefore going to be 1,000 centimeters cubed. Right, now this question can't possibly be about maximizing the volume because we are told the given information to us is the volume. What are they going to be asking us to minimize or maximize then? Well, have a look. This question says, write an expression for the height of the carton, which does not include the folded part, so just this part, in terms of x. And the next question says, find the value of x so that a minimum area of cardboard. So there we go. We're going to be having to model the area of the cardboard, and we are given the volume to help us connect the height and the x value, because we can't possibly have height and x in our formula. So what is the only information given to me that can help me? Well, the volume. I've been told that the volume is 1,000 centimeters cubed. Now they said that that's excluding the top. So basically this this rectangular prism has a volume of 1,000. Now we've done this before. The formula for volume is area of base times height. My area of my base is x times x, and my height is h. So actually 1,000 has to equal to x squared h. Area of base times height. Now it says write an expression for the height, so 1,000 over x squared is h. Now you might recognize this. This is basically why we did literal equations in grade 10. This is the beauty about maths. Everything builds to grade 12. So finally you can see why you did these funny sections in grade 10. That's a literal equation. Can you find h in terms of x? Okay, now it says, can we find the value of x so that a minimum area of cardboard is used for manufacturing? So we need an expression for the area of this carton. Well, what do we have here? Well, we've got the base, which we know is x squared. So we've got x squared. We've got the top, which we know is 3x squared, because it was 3 times the area of the base. And then what we've got is we've got the body of the rectangular prism, which basically is 4 sides, 4 rectangles. Now the question is, are those 4 rectangles all the same? Well, because this is a square base, every single one of those rectangles is the same. So there's 4 rectangles, and each rectangle will be x times h, so 4xh. Now you can't have h in the formula as well, which is why they tried to lead us in question A. So I'm going to combine those together, so that's 4x squared, and this is 4x, and h is 1,000 over x squared. So actually my area is 4x squared plus, and one of these x's would cancel, so it's 4,000 over x. Now this is a classic example of I have no idea what this function looks like. It's a parabola plus a hyperbola. It's completely weird. I have no idea. But I don't have to know. All I have to know is that this will maximize at a stationary point. So I need to find my derivative with respect to x, and then I can set it equal to 0. Now here's the problem. I can't differentiate yet because this x is at the bottom. And so just be careful that you don't launch into differentiation before looking if your function's ready to differentiate. So first, I'm going to bring that x to the top and make his his exponent negative. Now I'm ready to differentiate. So for x squared, bring down the 2, 8x, minus 4000x to there, minus 1, take away 1 is minus 2. Now I'm going to make my derivative equal to 0, and I'm going to take that x squared to the bottom to make it positive, and now I'm going to ask myself how to solve this. Well, I don't want to have x squared at the bottom, so I'm going to multiply by x squared. But when you multiply by x squared, you multiply everything by x squared. So 0 times x squared is 0, but this is 8x cubed, and here my x squared cancel. Now this is a cubic equation, and do I have to factorize? Well, fortunately there's only x in one place. So what I would do here is I would take my 4000 over, and I would divide by 8 to get 500, and then I would cube root. So much easier than factorizing. You probably wouldn't get a cubic that's super complicated and then you have to factorize. So look out for the shortcut. So I cube rooted both sides, and I got x is equal to 7,94 centimeters. I think this measurement was in. Everything was in centimeters. So yes, it makes sense. It's 7,94 centimeters. Now don't be alarmed if your answers aren't perfectly round numbers. In real life, perfectly round numbers don't always happen. Now, did we answer the question? It said find the value of x so that the minimum area of cardboard can be used. Yep. So if you want a milk bottle which can contain 1 liter, you actually want to have a square base of 7,94 centimeters if you're trying to minimize the amount of cardboard, which would then minimize the cost and maximize your profit. So it's pretty cool. Right, on to the last one. This is fairly similar to the next section. So it's kind of a bridging between the optimization and the next section, which is all about rates. So this question says, during a cricket game, A.B. de Villiers hits the ball onto the roof of the Wanderers Stadium. Taking the origin as the point of impact, the flight of the ball can be modeled using that equation. Now notice, they've given you a domain that this model is applicable for. Because remember, models aren't accurate forever, and they don't apply to all x values. So from 0, obviously you can't have negative, because 0 is where he hit the ball. So from 0 to 65 meters is where this model is applicable, where x is the horizontal distance the ball is gone, and y is the height above the ground the ball is gone. Both measurements are in meters. So this question says, calculate the rate of increase of the height of the ball when it is traveling 1 meter horizontally. So this is quite difficult because it's taking words and translating it into what this means mathematically. Calculate the rate of increase in the height. So that is, at what value is the y value increasing as the ball has traveled 1 meter? Now basically that's a gradient. Rate of increase in height is your gradient. So what is y dashed? Y dashed is, bring down your 3 minus 3x squared over 1000 plus 106x over 1000 plus 21 over 25. Now they didn't ask you just for your gradient, they said when you traveled 1 meter horizontally. So basically they're saying, what is your gradient when x is equal to 1? So y dashed would be, unfortunately, if x is 1, sorry, I shouldn't have written x. If x is 1, it pretty much disappears, really. So that should be really easy for us to work out. Now again, this isn't going to be a particularly nice, pretty number, and that's not a problem. In reality, these numbers aren't generally pretty. So I picked up my calculator and I worked it out, and I got 0,943, which means if I rounded it to two decimal places, the rate of increase in the height is 0,94 meters when the ball has gone 1 meter horizontally. So the tricky part of that question is not the maths. It's about translating the English into maths. So don't forget that when you see rate of increase, that is gradient. Okay, let's look at the next one. Determine the horizontal distance that the ball has traveled before it reached its maximum height. Now that's fairly easy because the ball's gone up and then it's reached a maximum and then it's gone down. So basically, I'm finding a stationary point. And how to find a stationary point? I need to make y dash equal to 0. Now, y dash I've already got. It's over there. So I'm going to say 0 equals minus 3x squared over 1,000 plus 106 x over 1,000 plus 21 over 25. Now, that's not a particularly easy question to solve, and so I would multiply everything by 1,000. It would make my life quite easy. So minus 3x squared plus 106x, and my last fraction, I just used my calculator for that, and I got 840. Now again, I don't want to factorize that. That looks hideously horrible, so I would just use the formula. So x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. Don't forget that you need to show your substitution into the formula. So please don't use fancy calculators that can do it for you and then not show your substitution, because there's definitely a mark for substitution in these type of questions. So I got x is equal to 42 meters. What do you know? It lands up with an amazing answer that's nice and round and neat, or negative 20 over 3. Now, it couldn't possibly have traveled negative 20 over 3 meters, so that is not applicable. Now, notice I know that's not applicable because this model only applies to that domain. So I can immediately kick that out. And the question says, determine the horizontal distance traveled. It traveled 42 meters. Great. Now, this is a type of question, as I say, this is in every exam, and it's the whole reason we do calculus. So we're going to need to practice quite a lot of these questions to make sure that we become awesome at them. Okay, well done.